I will run, I will climb, I will soar. I'm undefeated.
Assalamualaikum and hi everyone. So we continue with lecture 2. Now we're going to look the integral of f prime x e power of fx. So from the previous lesson, we know that differentiation of e power of fx would be f prime x e power of fx. So if you want to integrate in the form of f prime x e power of fx, the integration would be e power of fx plus c. Okay, then we look at example 4. Find the following integrals. Example A, integration of 3 times e power of 3x. From this integral, we can see that fx as 3x. So when we differentiate fx, we're gonna have 3. So we can see that the integration is in the form f prime x times e power of fx. So I can directly integrate to become e power of 3x plus c. Now for example B, we have 10x e power of 5x squared dx. So from this integration, we identify that the fx as 5x squared. So the differentiation of fx is 10x. Alright, so from this integration, we have identified that this integration is in the form f prime x times e power of fx dx. So by using the rule, we can directly integrate into e power of 5x squared plus c. Next, we're going to see the integral of the form f prime x times fx power of n. If fx is a function of x and differentiation of fx equals to f prime x, so as we know, differentiation of fx with power n plus 1 over n plus 1 will be f prime x times fx power of n. Then by reversing the process, so we have integration in the form f prime x times fx power of n. The integration would be fx power of n plus 1 over n plus 1 plus c. To see the rule clearly, we look at example 5. Find the following integral for integrations of x squared times square root x cubed minus 5. So I can rewrite this integration as x squared times x cubed minus 5 power of 1 over 2. So from the integration, we can identify that fx as x cubed minus 5. So the integrations of fx would be f prime x equals to 3x squared. Now back to the integration. For x squared, I multiplied with 3 to the x squared and also 1 over 3 to the outside and remain multiplied with x cubed minus 5 power of 1 over 2. So that our integration will be in the form f prime x times fx power of n. Then by using the rule, the integration would be 1 over 3 fx, which is x cubed minus 5 power of 1 over 2 plus 1 over 1 over 2 plus 1, and don't forget plus c. Then by simplify the equation, we have x cubed minus 5 power of 3 over 2 over 3 over 2 plus c. Then by dividing 1 over 3 over 3 over 2, so we have simplified as 2 over 9 x cubed minus 5 power of 3 over 2 plus c. Next, for example B, we have integration of 2x times x squared minus 3 power of 4. Okay, so from this integration, we took fx as x squared minus 3, and we know that the differentiation of fx would be 2x. So we can see clearly that this integration is in the form f prime x fx power of n. Then we can directly use the rule, so the integration would be fx, which is x squared minus 3 power of 4 plus 1 over 4 plus 1 plus c. So we simplify as 1 over 5 x squared minus 3 power of 5 plus c. Okay guys, we move to the subtopic 1.2, which is integration of trigonometric function. So at the end of the lesson, you should be able to find the integral of trigonometric function of sine ax, cos ax, and secant squared ax. 1.2 Integration of trigonometric function. Now we look at the basic integral of sine x, cos x, and secant squared x. As we know, differentiation of sine x is cos x. Then the integration of cos x is sine x plus c. And also differentiation of cos x is negative sine x. Then integration sine x is equals negative cos x plus c. We also know that differentiation of tangent x is secant squared x. So the integration of secant squared x is equals to tangent x plus c. So this is a part of integration that involve trigonometric function. Example 6. Find the following integral. For example A, integration of sine 4x dx. Alright, before we solve the integration, we first look at, let's say we have differentiation of cos ax. As we know, it's gonna be negative a sine ax. So by reversing the process, we're gonna have the integrations of negative a sine ax will be cos ax. If we just took integration of sine ax, then the integration would be negative cos ax divided by a plus c. So this is the formula of integration for sine ax dx. Then by using this formula, we can solve integration of sine 4x, so it would be negative cos 4x over 4 plus c. For example B, find the integration of 2 cos 3x over 4 dx. Before we solve the integration, first we look at the differentiation of sine ax. As we know, it will equals to a cos ax. So to find the integration, we're reversing the process. So the integration of a cos ax will be sine ax. So if you want to just integrate of cos ax, so it will be sine ax over a. So now we have the formula of integration for cos ax equals to sine ax over a plus c. So by using this formula, so we try to solve example B, which is integration of 2 cos 3x over 4 dx. So as we know, 2 is a constant, so we can put in front, so we just integrate cos 3x over 4 dx. So according to the formula, we have sine 3 over 4 x over 3 over 4 plus c. So 2 divided by 3 over 4, we have 8 over 3 sine 3x over 4 plus c. And lastly, for example C, integration of 2 secant squared pi minus x over 2 dx. Okay, before that, we might also look at the differentiation of tangent ax, which we know equals to a secant squared ax. So and for the integration of a secant squared ax, So it would be as tangent AX. So that the integration of secant squared AX dx, we're gonna have tangent AX divided by A plus C. So this is the formula of integration for secant squared AX as tangent AX over A plus C. Then by applying this formula, we're going to solve integrations of 2 secant squared pi minus x over 2 dx. So as 2 is a constant, so I put 2 to the front. So left with integrations of secant squared pi minus x over 2 dx. So according to the formula, we're gonna have tangent of pi minus x over 2 divided by the coefficient of x, which is negative 1 over 2 plus c. So 2 divided by negative 1 over 2, so we have negative 4 tangent pi minus x over 2 plus c.